Okay, so this is case study on Sears Holdings. Sears is a retail store, okay, a mid-sized retail store. Now what they did, what they were doing earlier was that they were using a combination of Teradata, Exadata and SAS to do data mining. Okay, they were using a traditional system like Exadata, Teradata and to store and process customer activity and sales data. And they wanted to understand how do their customers behave. Okay, now they were not using Hadoop earlier. What did they want to do? What did they want to come up from there? The same thing which I showed you just now in the point of sales. Okay, they wanted to understand how are their customers buying, what are their buying patterns, when do the customers buy, what are the kind of things they are buying, what could be the associated things they can buy if a particular customer is buying something, so that they can offer them deals and discounts, as well as they can map their behavior properly. So earlier they were using system Teradata, Exadata combination along with SAS. Now there were some issues which they were facing because of which they shifted to Hadoop. Let's see what was the challenge there. So you can also read at this link why Sears is going all on Hadoop. So this is one link which you can find in this PPT. This PPT will be available in your LMS, so you'll be able to look at this link as well. Now what was the challenge? So basically this is the place where you collect the data from the instrumentation, your point of sale instrument. You collect and you store the data on a grid. Okay, so it will be a huge data which will be stored. Initially what happens is that 90% of their data was getting archived. So after a period of time, this data becomes too huge to handle in this storage grid, and they were archiving this data. The storage here is a grid of computers where you are storing your data. Okay, this is not Hadoop. Usually the usual your storage area network kind of thing. And what you will be doing on this will be that after some time you will be archiving some data. Okay, at any point of time the active data which is available for processing is around 10% of the data, and 90% of the data is archived. Okay, so you have limited availability of data to analyze. Say for example a customer came 3 months back, you will not be able to look at that data. Archiving refers to putting that some data from an active level 1 storage to a level 2 storage like a tape, or to a level 2 storage, which is not actively used for analysis. Okay, so you in your offices you would have seen that there will be a tier 1 storage, there will be a tier 2 storage, then there will be everything will be stored on a tape going forward. And you look at the archive data only when there is a problem or something goes wrong, you pull that data back to do that. But then the challenge there is that if you cannot store such huge amount of data in an active tier 1 system, and that is why you could analyze only 10% of that data. Now if you analyze only 10% of that data, because the challenge here was that if you move it to a ETL compute grid, you will not be able to do that because of the limitations there. Now this data goes into RDBMS, then you run your BI and interactive apps basically to get an insight on the customer behavior. Okay, so let me repeat this once again. What is happening here? Here is your instrumentation and data collection. This data is getting stored into a storage network. Then a lot of this data gets this is all raw data. A lot of this data gets archived over a period of time. This data is moved into a ETL thing where you do extract, transaction, load. Everyone understands what is ETL? Right. Okay. So ETL will be used on this raw data. Okay, so we will be reading this raw data, we will be extracting meaningful information out of that data, and then we will be generating reports out of that based on the business requirements. Okay, so there will be some SQL querying done there. We will be looking at more into ETL as we go into this course, but for now you can understand it this way, that it will be you move the data into a data warehouse, okay, where you will be analyzing this raw data, you will be reading this raw data, and you will extract refined data from this raw data, okay, and then move it into and generate reports based on that. Okay, Sushil is asking me what is premature data death. Now see this 90% of this data doesn't make it at all to the compute grid at a particular point of time because of the huge size of the data. Okay, so the challenge here is that only 10% of the data is available at any point of time to generate interactive reports which can give you insights into the customer behavior. Okay, so that's what Sears was also seeing. And what they did was something like this. So they removed this complete ETL and the storage grid with Hadoop. Okay, now this complete data is available at any point of time to do analytics. Okay, you don't have to archive any data. You can actually put all the data together and do all the analysis together. Okay, so the challenge which companies face is not about storing that data. The challenge is about retrieving that data at a very fast rate and putting into a ETL kind of system. Okay, now what happens is that the storage sizes have gone up. They have scaled up beautifully. What has not happened is that the read speed from a storage is not increased. The read still happens at a very low speed. Okay, we will be looking at that in a while. So because of that, it is impossible to read all that huge data without using something like Hadoop. And I'll be telling you why, okay, in a while. So just hold on. Some of these things will become clearer as we move on. For now, you can just understand that with Hadoop, you are now able to utilize your complete raw data for analytics as compared to earlier system where you were using only 10% of that data. Okay. So the performance of getting data and everything we'll be talking about in a while. Okay, you will understand all those things. Okay, is that okay? Is everyone fine with that? So see, the crux which you need to understand here is that because of the limitation of not being able to get that data from a ETL, from a storage grid, okay, we had to archive a lot of data and we could use only some data. Okay. Now Hadoop has solved that problem and you have the complete data available for analysis. How is it different from the storage grid is something which we'll be looking at in a while. Okay. We'll be also looking at security in Hadoop, not in this class, but later on, Satish. Okay. So is that clear to everyone, guys? How has Hadoop changed the fact that you can now analyze a larger amount of data as compared to a lesser data earlier? Yes, Satya. So that's right. This is not only an issue of storage. It's not an issue of storage. You can store data, right? But can you actually quickly retrieve that data to do analysis? Let's see. I mean, I understand that all of you had that question on the last foil that why can't we analyze the whole data when it is kept, whether it is archived, it can still be retrieved and it can be analyzed, right? So let's see what is the challenge there. It's not about storage. This small example will help you in understanding that. Yeah, Utpal, please go ahead and ask your question. But meanwhile, what I want you guys to do is that look at this problem. So you have to read 1 terabyte of data. If it is kept on a single machine, which has 4 IO channels, which means it has 4 hard disks, and each channel has the read speed of 100 Mbps, which means it's a very good sophisticated machine. How much time will it take to read it? Okay, I want you guys to calculate that. Utpal, you can go ahead and ask your questions. Don't worry. And meanwhile, everyone, please try to do this exercise. Tell me how much time it will take to read 1 terabyte of data from here. Okay. So basically, this is the kind of time it will take. It will take around 45 minutes. To be precise, it will be somewhere around 43 odd minutes. But 45 odd minutes it will take to read 1 terabyte of data from a single machine. Okay. So all of your storage networks, when they are not distributed reads, will take this much time to read 1 terabyte of data. You can imagine if you had 500 terabytes of data which Facebook generates, how much time will it take to read that data? So the challenge, guys, is not about storing the data. It is about reading that data fast for analysis. Now, if you had 10 machines, if you had to read the same 1 terabyte of data from 10 machines, what will be the thing? How much time will it take? Yeah, obviously, it will take 1/10 of that time. So this is the whole idea behind introduction of a distributed file system, and that is what Hadoop is based on. Okay, it is not on processing power or anything like that, but it is on the ability to distribute the data. Okay, and a framework which can store distributed data as well as help in analyzing that data without facing all the issues like scheduling of data read and dirty read. All those things are taken care by the framework itself. Coming back to the same slide, if you look at, if you had a normal storage, it would, why do we archive all that data? Because it is not humanly possible to read that, it is not possible to read that data at a fast rate, right? So if you had to do that analysis, the importance is that the analysis should be done at a very fast rate itself. In case of Sears, they have moved to a 300 node Hadoop cluster, and to keep 100% of its data available for processing rather than meager 10% as was the case with non-Hadoop solutions. So what Hadoop does is it can distribute the data, and you can read data in parallel from Hadoop. Okay, so if you have 300 node cluster, I'll tell you what does that actually mean. But in this case, you can read from 300 nodes in parallel as compared to one very fast storage area network kind of solution. Okay, does that help in understanding this? Now is this much more clearer? But for now, have you understood how does Hadoop help in this particular case by making, how can we analyze all the data together? Because of that problem of reading that data fast, what we did was, instead of putting that data on a very high machine, a highly available machine, we put that data across a cluster of computer, which are say in this case a 300 node computers, from which you can read in parallel. And though the speed of read from each will be slower than what you could achieve by vertical scaling, which means by using a better hardware, but you still can read from parallel from hundreds of nodes, so you have all the data available for analysis at any point of time, right? Is that guys? Yes, data from point of sale, right? So does that answer all the doubts which we had at that point of time earlier when we were on this slide? Okay, so can I assume that it requires more investment on more nodes to process? Well, very good question. Now the fact is, with Hadoop, it becomes very cheap. One, Hadoop is open source, you don't have to pay for the licenses. Number two, these nodes are not really high-end machines, as we'll see as we move ahead, that these are cheap commodity hardware, so the price will be in fact lower. Okay, so that is the beauty there. Okay, Satya?